Hello students, so this video is for class 8 chapter sound. So let's start this chapter. Okay, so basically before starting with the word sound, we should know that we should know something about energy, right? And as we have learned in the classes that were going on, we have seen that energy can be seen or can be felt in multiple forms. Like you can see it in terms of light, sound, and heat again. So right, sound is nothing but you can say as a form of energy. Now, as far as sound is concerned, is something like that we hear, right? And there will be multiple categories that will be going in depth in this chapter itself. So if you for example, if you take a pen and right and a spoon and you hit it, right? So the moment you hit it on the different parts, you'll be having a different type of sounds, right? If you are hitting it on the top of a pan, then you might get some sort of type of sound, and if you are hitting at the bottom, then you'll have a different type of sound. So how exactly and what is the main reason for the production of sound, that we'll be studying in this chapter. So the basic reason why this we have different type of sounds or how the sound is being produced, you can say it is nothing but the vibration of particles that is responsible for the production of sound, right? And the moment you are like now exactly when we are speaking, you can touch your neck and you can feel the moment you are trying to speak something or humming something, right? There you can feel that vibration that is being responsible for the sound you are producing, right? So vibration, again, vibration is nothing but you can say a to and fro motion, means a particular object is there or they are moving continuously back and forth, right? This type of motion is called as vibration, and these vibrations are responsible for the production of sound, right? And it might be different type of instruments, the people when they are speaking. So ultimately it is nothing but the vibration that is occurring in the particles, which is responsible for their peculiar sound, right? And if you have to take into consideration the different type of instruments, like if you are having a guitar and you're plucking the strings of it, right? So each string will have a different type of vibration, and the amount of, or you can say the variety of sound it produces, it varies, right? Similarly, when you are trying to play a tabla or something, right, you have a flat skin like structure, and when you are beating it, right, the moment you beat it, the vibration that occurs or that of the membrane, that is responsible for the sound being produced. Or example, when you are playing a flute, right? So in that, when you're doing it, just nothing, doing nothing, just putting up or blowing up the air. So that vibration of particles, again, how you are blowing, that also is matters and varies, will be responsible for that specific sound that is being produced. Now, to understand more about the vibration, we have to again go back to the topic that we have discussed in the previous classes, that is your simple pendulum. And by simple pendulum, you know the basic structure. It's nothing but a metallic ball which is hanged with the help of a thread. Then there is a position that is called as resting position, and then we have two extreme positions which are called as extreme position only. There the exactly nothing is there. At the extreme position, the body is having only the potential energy, and at the resting position, the body is having only the kinetic energy. So in the book diagram that we have given, there are given as A and B are the position which are extreme, and D is a one that is a resting position. So at A and B, they have the body has only the potential energy, and at the D it has only the kinetic energy. Now there are several terms associated with the motion of oscillation. First one is amplitude. So distance, basically. You can say the distance from D to A or D to B is called as amplitude, means how far it can go from the mean position or the resting position to the extreme position, that is called as amplitude. Then we have one more definition that is called as time period. So basically it means the time taken by the pendulum to complete one oscillation, that is the time period. And you can say one oscillation is something when it starts its motion from A, it goes to D, then B, comes back to D, and finally it comes back to A. So from where the oscillation started, the motion started, and if it is coming back to its initial position, that is called as one oscillation. And the time period being taken for the completion of one oscillation is called as the net time period of that oscillation. Sorry. Then frequency. Frequency is the term, right, that we have seen in the generally in our common day-to-day life also. We have been using the word frequency. So in terms of this oscillation, or in the terms of this pendulum motion, frequency basically means how many oscillations are being occurring, right? So now it is very difficult to measure the number of oscillations that are happening in 1 second. So what we do practically, basically we calculate the number of oscillations being carried out in 1 minute, then we'll divide that by 60 and we'll get the frequency of that pendulum. Okay. Moving on, now comes the topic like how the sound travels. So you'll understand the beauty of it, that sound basically requires a medium to propagate. Here I'm saying to move from one position to the next position. It requires a medium basically. Then you can say it travels in air, solid and liquid. But as far as a vacuum is concerned, it will not be traveling. And when I'm saying that it will not be traveling in vacuum, you have a simple activity that they have given in your book, right? You have taken a metallic glass jar basically, and you have taken out all the gases or whatever that might be there in that, and you put up a setup so that there is electric bell inside that, and when you make the current to flow through that bell, right, then what happens exactly is like the bell will be ringing but will not be able to hear anything, right? So that basically is an indication that sound cannot travel if a medium is not there, right? Then moving on, we have the concept of rarefaction and compression. So basically, when even though now also I'm speaking, you are able to hear it. How actually, and this is the reason being that my phone would be, or my would be recording the sound and all. But how actually this sound is being produced is like. The moment we are saying, right, the vibration being produced are by vocal cords that will be transmitted to the medium surrounding me, right? So what happens exactly is like there are different type of particles which are present in like you can say gaseous particles or suspended particles which are present in the air. So the moment I speak, so these particles they oscillate, right? If I'm saying from here to here, if like a body person is here and is saying something, the particles will vibrate, or you can say oscillate, means they will be going back and forth their position, right? So when the particles will be near to each other, when they'll be congested, that area is called as compression. And when the distance between those particles is high, that time we say that the region is called as rarefaction. It's simple as that. When the particles are nearby congested in a particular area, then we say that is a compression region. And when the distance between the particles is very high, then we say it is a rarefaction region, right? Now moving on, we can see that light travels basically through water. So what happens exactly is like we can again perform the same experiment by taking up an electrical bell, putting up in a bucket filled with water, and the moment we try to ring that by passing current and all, we can hear the sound, right? And this also is there, like if you have to understand about how it travels in solid, then you can have two thermocol cups, right? And you can have a string, right? Then you would have seen this activity, kids being playing, then the one would be saying something and the other person who is at very far away can hear that. So basically through the strings, those vibrations are being able to transfer from one place to the another, right? Now something we have is to understand the basic structure of our ear. So our ear, now they have given a cross-sectional view of the ear. So ear is basically divided into three parts. That is your outer, middle and inner ear. Outer ear is nothing, that is a portion basically that is visible to you. Middle and the inner ear are not visible. And outer ear basically consists of eardrum. In Hindi we use the word kaan ka parda, right? Then a long canal you can see, and this pinna, right? This pinna, then from there we have a long canal, then it the final structure that you can see from outside, right, there is the eardrum. So these are the three parts, or you can say the portions which are present in the outer ear. Then in middle ear basically we have three bones, hammer, anvil and stirrup being the smallest bone in our body. I'm just saying the name of the parts, how it will travel, that we'll see now, right? In the inner portion we have a cochlea, and we have a eustachian tube, and finally which is connected to auditory nerve. So what happens is like when someone is saying and we are hearing something, it is the vibration of the particles that is coming to our ears, and somehow that vibration is being it will enter our ear through the pinna, it will go through the canal, and it will start hitting that, those vibration basically will start hitting the eardrum, and from eardrum the bones are connected in a sequential manner, right? So those vibration with the help of bones will be transferred to the cochlea, and finally it will be those magnitude of that will be transmitted to the auditory nerve, which will go to the brain and which will help us in understanding the vocabulary part and all, right? Now there are certain characteristics of sound, right? Like you would have seen there's a difference between the voice of males and females, right? So and there's a difference like when we can say when a fly is flying near to your ear, or a mosquito is flying, right? So those characteristics are defined with the help of certain terms. The first term being your pitch. So pitch something is called shrillness you can say, or you can say the तीखापन जो किसी की आवाज में होता है. The shrillness, basically we say that the woman's pitch, sounds pitch is basically quite higher. The reason being the sound being produced by them has a higher frequency, means the particles will be vibrating very high, fastly you can say, right? And as far as when a male is speaking, then we say that the bass of that sound or the loudness of the sound. So right, what we have to understand, loudness is something which depends on the amplitude, right? Means how much the particle is able to vibrate from the mean position, and frequency is something how fast the particles are vibrating, right? Then last one, we have the quality of sound. Basically it is called as the if a sound is being produced by two sources having same pitch and soundness, having same pitch and same loudness, then there is a difference in the quality, and that quality measure is something different, right? It is not a technical term that we can understand. Now moving on, what are the different types of sound that we can hear, right? Basically we have classified the sounds in terms of the frequency that we hear, right? So this range that is audible to human ears is from 20 hertz to 20,000 hertz. That is the sonic range that we can hear. And there are certain waves or certain sounds which are having frequency less than that. Those are called as infrasonic, you can say. And the something which has frequency higher than 20,000, it has they are called as ultrasound sonic waves, right? Now we have one more topic that is called as echo and sound absorption, that we again have to see. Echo is something like if you are in a very long hall, right, and you try shouting something, then you can hear the sound being produced or heard twice. Actually, it's like your sound waves will travel and will come back to you, right? So normally it is very common if you go to some hill station and you are shouting at the top of a mountain and all, then your sound will be reflected back. So basically sound are nothing but the waves which are traveling through a medium, and it will go and hit back, and then that's why again you are able to hear it. But if you go to some hall and all, and this again hearing back the sound, or the sound being heard continuously, is called as echo, right? Now if you go to a movie hall, right, they would have they are having very big speakers and all. So what they do so that this echo is not there, ultimately the experience of the movie will be ruined, right? So they have these different objects like cushions, wood and all, for absorbing the sound, right, for having a better sound quality and all. They have those things, right? Then there are different components like sonar technology is there, that is being used by the submarines and all, for just basically you can say for finding out the depth of the ocean, right? They will send the waves, they will come and hit back, and then they will measure the time, and with the help of that simple formula, speed, distance and time, they'll calculate how much is the depth of the ocean at a particular point, right? Now there are different instruments with which you can make sound, and I have said, right, there are string instruments basically that you can classify them. They're the one where the strings will be responsible for the production of sound. Then there are wind instruments like you can say bass, and then you have this and flute. Then there are percussion instruments like which are having a membrane structure like tabla and drum. Ultimately the main reason being we have to produce a vibration and the different sounds being produced. Now what is the basic difference between a noise and sound? Noise is something is a specific type of sound only, but which is not pleasant to your ears, right? Something which cause irritation to you, right? And the basically the what we have is like we have one more quantity, physical quantity called as decibel, that is used for classification of the sound, like whether it is a noise or a sound. So if anything unpleasant to your ears, you won't say it is a sound, right? You won't say it is a melody, you'll say it's a noise, right? And again if you go to some urban areas, some metropolitan cities, this noise pollution is causing a serious problem, okay? Like, and it has some mental effect also, like a physical effect also, that it may hamper your body growth and all. So how exactly it can be avoided is like basically we should do that industrial areas being there, they should be away from the residential areas. When you are traveling in a traffic jam, there is no need to honk continuously, even though you cannot stop or avoid listening to TVs or music and all, but it should be done at a very you can say minimum level, or that is comfortable to you and to the others people sitting next to you, right? And the certain areas are there, like when you are school or hospitals, the public gathering places are there, there some sort of limit should be there, right? So that's it from this chapter. See you guys for the next video.